And then during the sharing session, if let's say any of you have any inquiries to ask further to the speaker, you can drop your question inside the chat box and later on I'll pass it to the speaker. And then afterwards, kita also ada Q&A. And after Q&A, kita ada Kahoot online quiz session. So for our Kahoot online quiz session, semua orang boleh join. The public can join, MCMC staff boleh join. However, the top 5 winners hanya boleh consist of MCMC staff sahaja. This is due to our no gift policy. So during the sharing session, kita also akan throw away 3 soalan quiz kepada physical attendees. Siapa yang dapat jawab dengan betul akan dapat e-wallet RM10. Untuk the top 5 winners for our Kahoot pula, top 5 tu setiap seorang akan dapat RM30 e-wallet sahaja. And of course, both online and also physical, pemenangnya hanyalah MCMC staff sahaja. And also, sorry to say, the winners must not be from the user department, which is the stakeholder future enablement division. Sorry, yeah. All right, so without further ado, I would like to welcome our speaker for today, Encik Muhammad Hazwan bin Abdul Hafiz daripada A2Tech Sdn Berhad. He is the COO from A2Tech Sdn Berhad, and he will share a session today entitled Enabling the Industry Through AgriTech, Advancing Remote Operations in Oil Palm Plantations. And for all your information, we are collaborating with the Stakeholder Future Enablement Division for today's session. So I would like to pass on the microphone to Encik Muhammad Hazwan. So we hope to learn lots of things from you today. So dipersilakan Encik Hazwan.
Hello. Assalamualaikum warahmatullahi wabarakatuh. And a very good afternoon to honorable audience that are attending here physically, and also to those who are here online. Okay. And also today I brought also my beloved wife sitting at the back. So I'm going to be, by the way, my name is Hazwan, Chief Operating Officer of A2Tech Sdn Berhad. And today I will be sharing on my topic, which is advancing remote operations in oil palm plantations. Okay, maybe a little bit about myself first. So I was actually a student, engineering student from University Technology Malaysia. I think technologist Mr. Azrin also an ex of alumni of University Technology Malaysia, where my first engineering field was actually in mechanical engineering, graduating in 2015. Okay, so after I graduated from my studies, so I went to the industry actually, focusing on automation actually. Okay, so automation in Foxconn Technology Group. Maybe anyone here have ever heard of Foxconn previously? Okay, so Foxconn, I think, is actually known to be one of the largest, or maybe the largest contractor in the world making Apple products. So there's a lot of automation actually going on in the Foxconn team. Okay, so after that, since I was doing mechanical engineering previously, and inside the automation field, I noticed that I had still a lot of gaps, in knowledge, especially on the software and electrical side, which made me proceed to take my master's also in University Technology Malaysia in mechatronics and automatic control. Okay. So doing my master's, this is actually my final year project. I was doing on, okay, if you can see that there's a moving arm. Okay, it's a moving arm. So this is actually a human-like robotic arm. Okay, mimicking the human anatomy from the bones to the muscles, and also the mechanism of movement of the robotic arm itself, which is quite different from the robotic arms that we usually see in the industry actually. Okay, and this is a project actually in the domain of soft robotics. Okay. So maybe from the audience, anyone have ever heard of soft robotics before? Okay. So soft robotics is actually an emerging field in robotics technology where the researchers believe that uh, us humans and robots should be able to actually interact very closely and live together. Okay. So one main rule of robots is actually that robots are not supposed to be actually hurting humans. Okay. So there have been algorithms of robotic collaboration with humans, but one way is to ensure that all the materials used in a robot is actually made of soft materials. Ah, and if this robot does go maybe haywire, the algorithm is out of control, and it does, let's say, hit a human, then the human is actually in a safe condition. Okay, but one thing about soft robotics is it differs a lot with the usual rigid robots that we see people using today. So when we take a look at the rigid robots, we usually already have a very matured understanding, theory of how the rigid robots work, using inverse kinematics and forward kinematics in order to control the position of the rigid robots. But for soft robotics, because you are using elastic materials, okay? So while using elastic materials, these materials can actually bend anywhere in the substance itself, and this creates an infinite number of degrees of freedom inside the soft materials, making it very, very hard to control. Okay, so my work was actually in the algorithm of controlling these soft robots. And this time I was using a neural network algorithm to control the robots. Okay, so actually from this video here, what's actually happening is that I was putting the robot in a Vicon room. Okay, Vicon, it is this technology where you put markers. You can put markers on all the joints, and there are video cameras. There are cameras all around the room that actually track the marker's position in a 3D space, XYZ position. So you are able to study the movement of the markers, hence finding the movements of the links. So I use these positions to actually train my AI model to control this robotic hand. Okay, so this really brings actually a lot of opportunities, unseen opportunities, where if robots are able to work closely with humans, they're not only isolated, just like in the industries that we see now, they're isolated because they are hazardous, but this brings possibilities that even humans, we can even extend our capabilities. Maybe we might not even be using 2 hands, we can also be having 4 hands, okay, because of having soft robotics, which are not dangerous to us humans, okay? So now currently, I'm also doing my PhD right now, furthering my studies in soft robotic control algorithms. Okay, and this is controlling of the finger. Okay, if you notice that our fingers actually, like robots nowadays, rigid robots, all the movement is coming actually from the joints. Okay, but our body actually, our skeletal system, we have a lot of redundant bones and muscles and joints, causing humans to actually have a lot of more of dexterity than these robots. Okay, so humans, yeah, we can play the piano, play the violin, even we can harvest kelapa sawit kan? Kita boleh harvest kelapa sawit. Very dexterous movements that robots have not been able to achieve yet until now. Okay, so this is and this project was actually brought back from Japan by our beloved CEO, Professor Ahmad Atif, and was actually sponsored by Mitsubishi previously during his time in Japan. Okay, so here we can take a look at this is a remote operation also actually of controlling a robotic arm to move. But what you can see is it lacks the dexterity of the human, even though it's following my XYZ coordinates, but it actually lacks the dexterity that a human can actually achieve. Okay, and currently right now, I'm also currently the Chief Operating Officer at A2 Tech Sendirian Berhad. We are actually um, we are actually a very new company actually, and okay, so it has been an accelerating journey in A2 Tech Sdn Bhd. I would especially like to thank our team of very hardworking members that brought us until the stage we are now, and also our CEO, Prof. Ahmad Atif, sends his regards to all that is on the floor today, and he's very sorry he's not able to attend. Okay, so what is A2 Tech, and how was A2 Tech actually established? Okay, so A2 Tech actually came from a lab first in University Technology Malaysia, where Prof. Ahmad Atif opened A2 Lab in 2010, where his main research revolves around soft robotics and also mobile robotic platforms. Okay, and with the research in from 2010, in 2022, Prof. Ahmad Atif found that some of his research in mobile robotic platforms were ready to be commercialized. And that's when AgriTech was opened as a spin-off company. So we are very new in the scene actually, 2022. Okay, so what we do at A2Tech, we have three main verticals, which are robotics, AI, and also IoT. And these are some of our, zooming into the robotic side, these are some of our robotic platforms. Okay, the sub-verticals of robotic platforms we have for structure inspection, which is the inspector model. We also have robots in surveillance and rescue, which is named as extricator, and also in palm oil mechanization, which is the Rhino units. Okay. Okay. So these robots are actually remote operated robots. We can control these robots from afar due to some of the different concepts. Okay, and so our robots, there are actually two types of robots that we have. First one is the tethered unit, means that when we want to control the robot, that we have to connect them with cable, and we also have our wireless units. Okay, so from the command center, we can actually control these robots just by wireless communication. Okay, let's zoom in into the Malaysia palm oil plantation. Okay, as we all know, the Malaysia palm oil plantation is a vital and critical field in the Malaysian economy, where we are the second largest palm oil exporter in the whole wide world, with a GDP of 5 to 7% and an income of 109 billion in 2024 alone. Okay, so it is the backbone. It's one of the backbones of our country, and it's a very critical sector for our economy. Okay, and even though it is our backbone, yes, of course, we still have some elephants in the room. Okay, we still have some problems in the palm oil sector, and I believe that all the agencies and kementerian in Malaysia are trying to solve these problems. Let's take a look at some of the problems. Okay, I remember back in 2026 when I was still in Foxconn. Okay, so one of my bosses came from China. Okay, and he was talking about how he thinks the future of Industry 4.0 is actually going to look like. Okay, so he said that time he told us to close our eyes and imagine. He said, imagine walking into a production floor and it's all black, pitch black. Okay, there's no one there. So it's all black, but you can actually hear the machines at the back running. Okay, there are machines moving, and while no one is there, units and units of products are being produced. Okay, a very high level of autonomy. And where are the humans at this time? Okay, so the humans are supervising. The humans are supervising. They might be at the office, level 2 maybe. Okay, they might be also in other parts of the world, China, maybe even digital nomads in Bali maybe. But then the machines are running and producing the units, while any breakdowns, any breakdowns, another machine itself will try and fix the machine that broke down. Okay. So machine tu dia apa? Dia fix, dia punya kawan kan. Tapi kalau machine tu yang breakdown, maybe lagi satu machine yang akan fix dia, or maybe technical support from humans is also needed. Okay, so this is a very high level of autonomy and control that we are targeting, and this vision actually also applies to the palm oil sector. Okay, can also be applied to the palm oil sector. Okay, so we can also imagine the palm oil sector, which is the backbone of Malaysia, that is run autonomously, while our local operators, local humans, are actually here in the office supervising from afar. So everything in the palm oil sector is just done by machines. Okay, even though this looks like a very futuristic vision, but I can say some tasks are actually getting there, and are actually even one level that is one level before this level of autonomy and control. Okay, so from that vision there, we can see what is the gaps actually from our current technology to this vision. Okay, so some of the problems in Malaysia palm oil fields: no real-time visibility. Okay, not all of our palm oil fields have real-time visibility. Okay, these trees and plantations in the these plants in the plantations, they are all actually giving us some kind of data. Okay, they are giving us data, how the tree diameter, the canopy area, the moisture, the temperature. So all these are data that is actually given out by the plants and the earths. But we have to be able to read them, project them in a dashboard, analyze and do some action, take some action, looking at this the analysis of this data. Okay, manual data reporting. I believe a lot of plantations still are doing manual data reporting. Yeah. Okay, and this manual data reporting, no real-time visibility, actually causes the delay of decisions. Okay, delayed decisions, low efficiency, losses and theft, safety risks, and also all the technologies, the new technologies that are coming in, we still haven't figured out yet the integration. Okay, I think there is one more very famous problem in Malaysia palm oil fields that maybe some of us might know. Maybe the number one problem that is always being talked about, or known as MARCOP, as the three elephants in the room. Maybe anyone knows about the three elephants in the room? Okay. Okay, so elephant number one is workers. Okay. Anyone knows number two? Buka masuk kat pintu. Okay, so the second one is also actually workers. And maybe anyone knows what is the third elephant? Yes, workers. Thank you very much, Mr. Lofty. Okay, so we have some souvenirs. This one here is actually limited edition. Boleh tu? Keychain. Okay. Okay, this is a limited edition keychain. Since 2002, we are going to stop production of this keychain next year. Okay, and change to another robot. Saya bawa dalam 20. 20, okay. Semua dapat, okay. Okay, nanti saya dah tick nama Encik Afia. Okay, so workers, and workers, the three elephants in the room mentioned by Markov, and all these other related problems. So this is a very critical problem that actually can be solved by one of the SAWIT challenges in Agri NXT. Okay, so it's a very critical problem, and Agri NXT is trying to solve this problem, where our problem is on remote operations in palm oil plantations. Okay, so what does remote operations actually mean? Okay, what does remote operations actually mean? Remote operations ni, okay, when you talk about remote, that means you are from a distance. You are jauh, okay, you are from distance. But even though at a distance, you want to read something, you want to control something at a distance. And this is done by the transferring of data. Okay, so when the data comes, okay, either receiving or transmitting the data for controllability, and receiving the data from sensors. So this is actually remote operations. And remote operations, there are remote operations where humans are involved, and also remote operations that less humans can also be involved. Okay, so let's take a look at what are the main stacks of remote operation. Okay, so these are the three main operation stacks, or maybe we can also name them as layers of remote operations. Where firstly, the first remote operation stack is actually the sensing layer. Okay, the sensing layer. Okay, this can be done. Okay, like us humans, we all have our all these senses in our bodies. Okay, if we feel pressure, to feel temperature, to feel salty or sweet on your tongue, if you feel hurt. Okay, so we also have, with the use of electronics technologies, we also have all these instruments, all these sensors that are widely available in the market currently. Okay, so these sensors right now we can read hundreds and thousands of different types of data. Right now we can read temperature data, moisture data, soil data, and the list goes on and on and on. Okay, there's so many things that we are able to read, and the sensors will capture the data, will turn the physical form into an electrical form, and send it over to us by data. Okay, so the next component is the analytics component. This is actually the component that helps us perceive, analyze what is happening, turning data, messed up data. Raw data is very messed up, very noisy. It goes to some filtering and conditioning until we get very clean data, and this data can be shown and visualized on a dashboard. And with the use of statistical tools, maybe even tools like Minitab, we can actually use statistics to analyze the data, and also the newest technologies in AI to actually give us some inference on the data. Okay, so we have the sensors give us data, and analytics part will show us and will give us an inference of what is our next decision, what should we be doing next, ladies and gentlemen. Okay, so the third component is the action component. So once we have analyzed the data, we know what to do now. Now it's time for us to execute. So what are we going to execute? How are we going to be executing this? Okay, so we can either, maybe let's say we can have a decision to put more fertilizers in one spot, maybe precision agriculture. We can either add more moisture into the soil. We can start harvesting. So these are all some actions that can be done by using actuators. Okay, so actuators are components that you give them electrical signal and then they change it into physical force, mechanical force. So this is the full control cycle, sense, analytics, and actions. And if we go deeper actually into this theory, we will find other types of layers, such as the communication layer and these other layers also. But these are the three main. Okay, so now let's take a look at remote operations, the control levels of remote operations. Okay, so this is actually standardized table, also actually used by NASA, and this control level was actually created even before the autonomy control level, and the autonomy control level was actually inspired by this table. So let's take a look at the five stages, or I mean the 6 stages, because we include level 0. So they also have level 0, which is actually very low or no control in remote operation. Okay, so level 0 is actually the manual mode. The manual mode. So as humans, we still have to be there, sit in the on site. If even though if there are sensor data, then we have to be reading them on site. If we want to, let's say we are looking for ripe palm oil fruits, then we have to be on site. We have to check. We have to do everything manually. Okay. The second level of control is tele remote. Tele remote. Okay. Tele itself is actually a Greek word. It comes from a Greek word which is far. So you are actually controlling or getting something from afar, but for this, still the controls and the readings, analytics, this right here is actually all done by the humans. Let's say IoT, okay, the IoT technology. So IoT technology by itself is actually still on level 1. Okay, if you get the sensor readings, and then you read it and then you make some kind of decision, this is still at level 1 of a control level. So even the advanced technologies, but since they are practical, but they're still at level 1, so still far away to reach the full autonomy level. Okay, second is the shared control. Okay, in shared control, so even though the human is present, but the system has already some logic in order to automate some of the processes. Okay, so let's say when controlling a robot in a palm oil plantation, okay, so the first one in level 1, you are controlling left, right, go forward, go backward. Okay, but in level 2, you are now already setting up waypoints. Okay, you are setting up waypoints, and the robot has some algorithm to have some autonomy. It can choose how it's going to move to the waypoint and how it is going to actually handle all these obstacles or these other things, but we are still setting the waypoints. Okay, so level 3, this is supervised autonomy. In supervised autonomy, we can already give the robots the goals. Okay, I want you to check the ripe fruits or the black bunch count at plot number 1. So and the robot will be moving to the waypoint and waypoints automatically and checking this area, but still the human needs to monitor the robot, and if there are any exceptions, the robot will still come back to the human and ask the human, should I do this, should I do that. Okay, so we still need to supervise. But at level 4, okay, during my time in Foxconn, I would say that the machines that I was handling, we were at level 4 of autonomy. Okay, so the machines, even if I come to work, if I don't come to work, the machines are still running. They have their goals, and all this is only monitored by the KPI of the machines. Okay, so we will have a dashboard. Okay, because my machine speed It's actually very slow speed, but it is actually 40 units per minute. Okay, so my machines that time could produce about 40 units per minute. And this is actually quite slow. They are very they are also very faster process in the industry right now. Okay, so whatever I am doing, I can monitor the KPI from remotely. I need to make sure that there are 40 units per second, and at the end of an hour, we are able to get 2,400 units. If this benchmark is lower than this benchmark, then this time I know that there's a problem in my line, and at this time I'm going to be deploying some support, maybe some technicians, or maybe I come there, troubleshoot what's happening to the machine. So we actually there's a KPI for these machines that we will check if they are okay or not. Level 5, this is full autonomy. So the vision that my bosses in China at that time were actually talking about was actually just one step. And this was in 2016, ladies and gentlemen, was just one step after, okay, which is full autonomy. The machines, they produce all the units. If the KPI is not met, then the machines itself will optimize itself. It will make the KPI meet. But this is still very rare in the industry today. But for tasks and applications that are at level 4, this is the new target of level 5, where industries are going to, and actually no humans are required. Okay, so even though this is just a scale, a guide, but why is the control levels very important? Okay, for developers, when you know the control levels, you actually know what is the skill set that you need to advance yourself to the next level, and what is the technology stack that you need to be using in order to go to the next level. Okay, for leaders, entrepreneurs, tech leaders, especially, by knowing the levels, then we are able to create a roadmap of our technology development cycle. Okay, so usually we're going to start with looking at the manual mode, and then the first step is of course to go to the tele remote mode, and then jump on to the shared control, and then until the next steps. Okay, so we can plan when our technology is going to go ahead. And because when we are talking about development, then also cost of development and time is also involved. So we know that when is the right time we want to go to the next step, and what is the funds that is actually needed to make our development go to the next step. Okay, next, for individuals. Okay, why do individuals need to know the level of control? Okay, I think a lot of us here maybe have experienced this before, where people are actually asking us, will AI take our jobs? I think this is a very a question that I hear very often. Will AI be taking our jobs? Will all these robots be taking our jobs? Okay, so there has been a lot of answers that has been given by different people all around the world, even CEOs. I think Jetson Huang, CEO of NVIDIA, mentioned that no, AI will not take your jobs, but those that take your jobs will be people that know how to use AI. Okay, is it true? Is it not true? Okay, maybe others like Elon Musk, maybe they say things like, yes, there is a possibility that AI will take our jobs. So which is the actually true version? What anyone maybe what's your take on this? Okay. Okay. Yes, very true. Thank you, sir. Thank you so much, sir. Okay. Okay. Okay, thank you, sir. Okay, so that's very true. That is very true, and this is the level or the table that we can actually analyze this. Okay, so what the CEOs are talking about, if they are going to take our jobs or not, I would say we can refer actually to the level of control. Okay. Okay, let's see. At level 0, okay, the humans operate on site. This does mean that the humans on site, the skill set that is needed is actually the skill set to be on site. Let's say to do the harvesting, you will need this type of skill set. The skill set to maybe assemble. Okay, so this is you need high human workforce to be on the field for level 0. Okay, and for Malaysia, this is actually something that we do want to reduce. So we can also be taking a look at this, the control levels. Okay, so for level 1, direct remote control. What does this mean? So this means that what skill set that we need to find for tasks and activities that are in level 1 is actually we should be able to know how to operate or control different types of robots, different dashboards, different systems. Okay. For level 2, it's a bit like level 1. We know how to operate on the robots and what we use. Okay. Supervise supervise anatomy and also hide anatomy. Here we need all the data scientists to read the data, statistics, and then come up with decisions and also actions. Okay, so different skill sets that are needed for different levels, and these levels are actually applied to different tasks. Okay, so different tasks are actually at different levels of remote operation control, at different levels of autonomy. Okay, so maybe we can take a look at what is our everyday task right now and which level AI robotics is it at right now, which level of remote operations is it at right now, and we can figure out what are the relevant skill sets that we need to have to move up a level. Okay, so level 5. Level 5 is a very tricky level. No humans are involved. Okay, so what does this mean for us? For me, if I take a look and analyze at level 5, full autonomy, who does it really benefit? I would say it would benefit the business group. Okay, because if we want at this time, if we want to create a business, then we do not need any more manpower. Okay, if we have the capital, we can automate everything. And at this time, I would say that people will be coming up with newer and newer services using the technology at that time, which is fully automated. Tak ada pekerja-pekerja. Okay. So this is the time of the business, the business group. Okay. Next, let's look at the remote operations, the real-time preferences for remote operations. Okay, so this is actually according to the application, whether you need real-time operations, near real-time operations, or even not real-time operations. Okay, and this real-time operations, is actually also based on the wireless or the transmission technology that you choose to use. Okay, so some technology is not too critical on the latency, while some technology are very critical on the latency. And if you can see, real time is about below 100 milliseconds. Okay, it's not that obvious, it's below 100 milliseconds. So a few technologies that do fit in below 100 milliseconds maybe can be Wi-Fi, can also be 5G, 4G, but maybe some that are unsuitable is maybe like LoRaWAN. Okay, so it's according. But then real-time operations, when do we really need real-time operations? Is when the task or application is actually critical to be conducted in real time. Let's say a robot that is traveling on a cliff. So if we lag a few seconds, not real time, the robot may topple, maybe fall off the cliff. Okay. So and when does it need to be non-real time? Maybe some, let's say we are finding for the ripe fruits. Maybe this one does not have to have be real time. It can be you can get the data a few minutes after, and it would not make too much of a difference. Okay. Okay, so let's take a look at some example of remote operations. Okay, so this is an IoT station for soil sensors. So this IoT station we have deployed in Hutan Paso right now, and it detects moisture, soil temperature, electrical conductivity, pH, nitrogen concentration. So it detects the presence of the soil, and just by reading the sensors. So this is actually at control level 1. We are just reading the sensor values. There's no operations that are taking place. We do not control any actions over here. There's no so anything we will be deploying manpower. The decisions will be made like that. Okay. Okay, this is one of our drones that we integrated the footage with AI for tree counting. Okay, so as the drone is moving, it is counting how many trees there are in the kelapa sawit. Good for surveying. Okay.
Cik Hazwan,
yes.
yang different colours tu because dia easier for the AI untuk count ke ataupun ada maksud dia?
Oh, okay. This different colors is actually okay. Okay, so the different colors actually these are random colors that are actually showing the bounding boxes of the trees. So when you see the trees, they are
nampak pattern macam mana dia counts tu.
okay. But then how the counting mechanism works is actually we have a line down here, and you can see that there's these squiggly dots showing the center of the bounding box. Okay, when it finds the tree, it's going to bound the box, and then it's going to have the center. When the center lalu the ni threshold bawah, and then it's going to
cari
be
detect
counting
tu
the trees.
center, so memang dia kita macam confident lah kan, dia memang detect dan dia count sebatang macam tu.
Yes, true.
Faham?
Because if we lose the capture of the tree, nanti dia akan double count. So then instead, the way is to when the trees lalu je, then dia akan count. This is one of the methods. But then one thing, very good question, madam. Thank you. Okay, so one thing about this is actually you can see the field of view. There are some trees on the sides that are not counted. So there are other methods that are actually used to count and survey the palm oil trees. Okay, this is also some data from drone. This is orthophoto. So the drone's feed is stitched all together. Okay, the hectares are all, the frames are all stitched together, and you can get the whole stitch image. Okay, and by using this image, okay, this is another orthophoto, orthomosaic. Okay, there are a lot of analysis and analytics that can be done by just using this data. One of them is like slope analysis. Okay, you can get the slope at the regions, the intended regions. You can get maybe this one here it can be used for planting. Okay, when you want to plant the new trees, so you have to know the slope. There's a maximum slope for planting that you cannot put the trees, and from here you can already plan. You can also already make decisions on where you want to put the trees and the positions, locations. Okay. Here's also slope, but in map. Okay, and this is a dashboard that you can actually compile and put all the drone auto photos inside, so it can even pick where the location is in Malaysia and save the auto photo for doing further analysis. Just drop your photo inside, and here other than getting analysis, some analysis can also be done. Is also the coordinates of the trees, so where the latitude and longitude of the trees itself, and also can be further analyzed with some use of AI. Can also get the area of the canopy. So the area of the canopy, this does have studies have shown correlations, the area canopy with the trees health. Okay, so this is one way of monitoring the trees, just by getting the drone data, uploading, getting the canopy area, and uh, and then plotting we can also plot and export the numbers. What is the crown area, at which latitude, longitude. We can filter and see which area has low crown area, which has higher crown area. Uh, okay, we can put it on the heat map. So from the heat map, we can actually see that there are different colors. I think sometimes when analyzing too much data, it's very hard to visualize. So heat map helps you actually see where the smaller crown areas are and the bigger crown areas are. So let's say the smaller crown areas are over here, maybe detecting a health issue. So we can deploy people here to do some troubleshooting, or maybe add fertilizers, maybe pesticides at this region only. Okay, so usually they do the blanket spraying. So this is actually precision agriculture with the use of remote technology. Okay, this is something else that we can do with the drone data. We can actually turn it into a digital twin and put lump all the info inside the digital twin itself. So it's better for us to visualize. Okay. So next technology like geomapping. So this is one project that we're also doing inside the forest, where we are actually deploying a robot dog. Okay, we are deploying a robot dog to actually find for the diameter of breast height of the trees. Okay, together with the diameter of the tree and also the canopy, then we are actually able to count the carbon stock. Okay, so what it does is the robot. Oops. Yes, sure. Mm-hmm. 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 Yes, betul. Yes, betul. Yes, betul. Because of there are some indicators that show that the tree is in healthy condition or not. Adakah dia sihat ataupun tidak. So, apabila kita produce satu heat map dan kita nampak yang pokok-pokok yang kurang sihat berada di satu kawasan, dan itu adalah kawasan yang we can target. Okay, adakah daripada segi meracun ke, daripada segi baja, ataupun segi water ke. So this all can be shown by finding signals that correlate with the tree health. Okay, so kalau kita tahu pokok mana yang sihat atau tidak based on different types of data. So these trees memang tengah beri kita data-data yang dia tengah tak sihat, and dia semua berlaku dekat satu kawasan. Then this is the targeted kawasan lah. This is one thing in visibility lah. So when in visibility, you can actually supposedly kita boleh monitor. Okay, even though large plantations, vast expansion of plantations pun, kita still boleh monitor each and every corner, mana yang sihat, mana yang tak sihat. Okay, like my machines last time in Foxconn semua, if we can check the output, we can check even the speed of all the little processes. So kita actually from home, from my office, kita actually boleh tahu mana satu mesin yang sihat tak sihat. Kadang-kadang bila kita tengok, kita dah guess lah. Oh, okay, ni ada something ni berlaku ni. Kan? Even we can show the rejects. Selain daripada output, ada yang rejects. Okay, so kalau rejects banyak kat this kawasan and this kawasan, then kita boleh target. Okay, this and this, this is something happening over here. Kan? So this is the visibility. Okay. Okay, very good question. Okay, so this is what we are striving towards, the next level of controllability. Okay, so at some plantations, when we still don't have this technology, then kita kena buat decision. Okay, what do we have? Manpower. Okay, manpower pergi sana, check what is happening. Okay, do these actions here. Okay, or maybe kita boleh even check dia punya integrity. With this data, we can check. Oh, okay, ni team ni tengah ada masalah sebenarnya. Team ni ada masalah, team lain okay. Wherever they go and this happens, this happens. So you can also filter by that. Okay, but once we have the technology, kita ada drones ke, kita ada robots to go over, then this is the next level of autonomy, next level of remote operations control. And then this is the next level that we want to try and strive for. Okay, so I think the robotics companies banyak in Malaysia semua, this is our next target, to bring these robots into the agriculture field supaya we can increase our control, remote operation control level, supaya we can reduce the number of humans that need to be on site. So apabila kita dekat kita bekerja dengan kawasan selesa, this might attract even more locals yang Gen Z kan, untuk bekerja di satu tempat yang selesa, while controlling from afar. So then lebih pada guna otak to analyze, to make decisions, and then barulah deploy any type of robots for action. Okay, thank you so much for the question. Okay, so okay, so what this robot does, it actually moves. Okay, it moves around the trees with the use of laser technology, LiDAR. Dia akan dapat map all the trees, and then from GPS RTK, dia akan dapat tahu by mapping the XYZ of the tree on the point cloud to the real longitude latitude locations by using the GPS. So it's able to identify the tree longitude latitude and berapa dia punya diameter of the tree. This is also correlates to the health of the tree also actually. Bigger diameter, then it shows something, smaller diameter shows something, and also you can see the trend from years to years. Adakah the tree ni membesar ataupun tidak membesar? So we can know the health very fast, even without waiting for the final results. Okay, so this is one thing that we plan to do also, to check the fruits in palm oil plantations. Okay, using a robotic dog moving. Right now banyak teknologi, banyak players doing AI for finding ripe fruits, black bunch count. Okay, so kita program je the robot dog to masuk je ke kawasan plantation. Okay, kita sit back, minum kopi kan, and then dah keluar dah kat dashboard how many trees are ripe yang perlu di harvest, how many fruits are currently tengah fruiting, how many trees yang tak ada fruits. All this data can be delivered right to us. Okay, this is one of the macam point kata tadi, the actions. Okay, so if the dog, if this system is ready fully automated, let's say dia jumpa yang ripe, dia akan bagi yang ripe punya data dekat robot untuk harvest pula. So robot harvest pula akan datang. Robot harvest akan datang, dia akan harvest pula buah tu. And then robot collector pula datang, dia ambil, dia letak pula dalam bin. Okay, so end-to-end process of robotics. This is our target. We are not there yet, but this is the current target I think that Malaysian plantations are striving to. Okay. Okay, just another system detecting counting plants. This is the UTM gate actually, and this is like some sort of the dashboard. Okay, so any of the data comes in all through the dashboard, easier for visualization. Tapi visualization saja, there's no inferencing here. We make our own inferences. Okay, the use of AI can help us make these inferences. Okay, so let's say this one, you can see that most of them are cars. But then this is our analytics kan. But then if you tell, I think if you send this to AI, ChatGPT pun dia akan cakap banyak cars. But some things in the trend maybe yang kita tak nampak, this one here even AI can help us with also. Okay. Okay, this is one of this is our actuator S. This one here is used for patrolling. We are working with DRB HICOM Auto Solutions, and has also a quite high level of remote controllability, where this robot bila dia dah habis bateri, dia akan terus balik untuk charge. Dia akan terus balik to charge dekat charging station dia. Also can be done in palm oil plantations also in anywhere agriculture plantations. Okay, so awal-awal we just set a map, a waypoint, random waypoints that it needs to patrol, and then the robot akan do their own patrolling. The use of AI, sensors, we have the temperature camera, also normal camera, RGB camera. It detects people using AI also. Detect people, detect intruders, detect different kind of things so that we can teach the AI. Nanti when it detects any intruder some sort, nanti dia akan bagi buzzer, dia akan bagi actions, lampu akan terbuka, dia akan inform dekat command center, keluarkan report, auto generate report, even hantar kita telegram also can. So we know what is happening at our side. Okay, so seorang je perlu monitor inside a remote area, and then all the rest is done by remote operation technologies. Okay, so this is our Sawit 5 challenge and problem. This is what we delivered to the team. Okay, it consists of 3 elements. The command center, okay, kita control dia daripada jauh. We have the thing that we are controlling is our teleoperated robot. Robot ni digunakan untuk mengangkat sawit. Is actually representative of the wheelbarrow lah. Biasa orang pakai wheelbarrow nak kena angkat tons of kilos and kilos, tons of kelapa sawit per day, pergi jarak yang jauh. Memang sangat memenatkan and sangat kurang atraktif kepada our local workforce actually. Okay, and together with the AgriTech digital platform software, this is the software that does all the transmission in between, that assist the the transmission technologies to transmit from the teleoperated robot to the command center. Okay. So different types of robots. The one that we tested on, it was our fresh fruit bunch collector. So we have other robots also working with other players such as MPOP and etc. Okay. So just some specs about it. It can go 1 meter per second. Battery life also can last up to 8 hours and can carry 300 kilos of fruit. Okay. So let's take a look at a few modes. Okay, this one here is actually more to level 0 control level. Okay, so that's just me controlling the robot. Okay, we move, and this is actually the current method lah. The current method for mechanization. But then right now dia guna petrol. Dia tak gunakan electric lah. This is all electric. So then we have this option too, level 0 control. It might be more easier for the current people to adapt to. Okay, this is remote control, about 50 meters. We think this is more suitable for deploying the robot, getting it off our vehicles for logistic purposes. Okay, and next, this is the long range one that we tested in palm oil plantations. Okay, so we were able to, with help from the whole team, we were able to control this robot from about 1.5 kilometers inside palm oil plantations. And actually it could be extendable, okay, according to the number of knots. So we used 3 knots, and then we were able to control about 1.5 meters. And we do believe if we add more knots, then we will be able to extend this distance according to the number of hots. Okay, so this one here is using Wi-Fi technology in meshed, okay, mesh Wi-Fi technology. So we create a mesh at the palm oil plantation, and wherever the robot is, then it's going to be hopping from knot to knot until it reaches the robot, and the robot can also act as a knot. Okay, so let's see. Okay, and this is also okay. Okay, so we can control from afar. I think you can see the yeah, below. Okay, some features that we put in also to increase the level of remote operations control to go towards a more autonomous state. Okay, so here is one of them. We have the AI detection of loose fruit, and right now it's still in manual, but it's in the right now it's currently on research of how to make this automated. We are already able to detect the loose fruit, but now we just want to make it autonomous. So dia sekali jalan je, and then whatever loose fruit it finds, and then it will suck this. Okay. Here is also another initiative to go into a higher level of autonomy. Okay, remotely is the follow me mode. Okay, you can see from the first video there. Okay, so it follows the operator. This one. Okay, so you can ask the robot to follow operator by giving a sign, and then it will follow. It will follow us, and we can also give it a sign to say stop. Okay, so this is from the robot's point of view. And the second one here is from a different point of view. Okay, so it's following the operator. So this is more practical. When it follows the operator, then dia boleh follow kita, and then kita tinggal nak angkat buah aja masuk dalam. Okay. Okay. So this is also a future extension that we actually okay. Yes. Okay, so this is actually what we plan for further development of this robot. So dia bukan setakat ni, dia akan increase lagi level of remote operations dia. Di mana not only the can it move but and detect the buah, tapi bila nampak buah dia boleh angkat juga. Okay, so lebih autonomous. Boleh kurangkan lagi the manpower that we need on site. I think that's the key. Yang ni dia detect buah saja. Dia detect buah saja. Awas dia detect buah saja. Tetapi banyak players memang tengah buat models, AI models yang memang boleh detect the ripeness of the fruit. Kait, I think there are a few players yang tengah buat kait. One of them is the latest one is from Sarawak. I forgot the name. If I remember the name, nanti saya akan beritahu lah. Okay, so bila dah ripe, yang mekanisasi itu lah yang akan pergi dulu. Tapi this one here is more focus on the buah yang dah jatuh, yang dah di harvest. Okay, so on the ground dia tinggal lalu. Kalau tak sebelum ni apa nama dia? Sebab selalunya yang angkat ni dengan yang harvest ni adalah orang lain. Harvest dia memang harvest saja. So after dia dah harvest, nanti yang tukang transport ni akan datang, dia akan masukkan dalam, and then dia transfer to the bin lah. Okay. So these are some for future work after doing this. Then kita nak buat obstacle avoidance and rhino, and then sebenarnya some of these are actually done on our different robots. Tinggal perlu cari some funds in order to put it on this robot too. Hmm. Okay, so now let's take a look at first of all, I would like to take this opportunity to untuk ucapkan terima kasih. Thank you very much to organisers MCMC that got us through and selected us in the Agri NST and Agri NST chapter, where I think the Agri NST's role are three very critical roles. For us as startups, first of all, I would say is facilitate industry collaboration. Okay, so during the Agri NST session, we were introduced and networked to three types of main players. First of all, was the problem owners. Okay, so problem owners and also the solution providers too. Okay, so kita di pairing dengan uh, MPOB and we did the validations at real site. Okay, next was support innovation and development. We were given a fund to help develop this robot supaya boleh ditest di ladang. And third is very very important, which mereka support the real world validation. Okay, so during this period we were at Kluang, at Plantation MPOB Kluang for 1 week at that time there to test our robot. And real world validation is very important to in our development cycle, disebabkan our robot ni kita nak capaikan technology readiness level 7. TRL7 ni, technology readiness level 7 ni adalah apabila kita test robot in an operational environment. So we were brought to the palm oil site and the robot was tested in operational environment. We did the testing for a few days, and from there kita dapat refinements untuk our next iteration. But after technology readiness level 7, then this is usually the time where our products we can boost for marketing and sales, and all of this can actually be summed into this one picture. Okay, so these are all the players that came for the last day, the demo day, and our robot in the middle carrying the fresh fruit bunch. Yes. This is the real robot. Okay, this one here was the design only. Okay, so all these were the design. This is also the real robot. Okay, this is also the real robot. Ni robot yang sama. This is robot that we already tested in the palm oil plantation untuk utik buah, and this is where it's proven that even 1.5 km, even dengan heavy kita ada 2 cameras pun, tapi kita still boleh transfer, boleh tengok the live streaming, real time streaming of the camera and control of the robot even though dah 1.5 kilometers. Okay, so ladies and gentlemen, last thing for me is that remote operation means that no distance is too far. Not with robots, not also with us Malaysians. So with that, I would like to thank you very much.
Thank you, Encik Hazwan. So we thank Encik Hazwan for his knowledge sharing session just now. So before we ended the session, Encik Hazwan boleh tak nak minta tolong throw away the 3 quiz questions to the physical attendees. Siapa dapat jawab dengan betul dapat e-wallet RM10 setiap seorang. So kita ada 3 soalan untuk diberikan kepada peserta fizikal kita sahaja.
Okay, Assalamualaikum, I'm back. Saya lagi. Okay. Question number 1. Which process in remote operations collects data from the field? Analytics. Are you sure, Tuan? Collects data from the field. From the field kita collect. Yes, sensing. Okay, thank you very much, Tuan. Yes.
Okey, tahniah. Jadi soalan
Tahniah,
pertama
tahniah.
dah ada pemenang. Okey,
Tahniah,
soalan
tahniah.
kedua.
Okey, soalan nombor 2. Oh, apa? Tak dapat A, B, C, D. Ni sebenarnya objective question. So, ada A, B, C, D. So, even without A, B, C, D, tuan ni boleh dapat jawapan dia. So, betapa kuatnya ingatan. Okay, question number 2. Which industry challenge can remote operations help solve in palm oil plantations? Yes, sir? What? Yes, thank you very much. Labor shortage, lack of workers. Okay, thank you very much. Ni pun sama juga ya. A, B, C tak keluar lagi tapi still boleh jawab soalan ni ya.
Dah fokus.
Thank you. Very focused. Thank you. Okay, level number 3. At which, ni susah sikit. At which control level can a robot perform a task by itself but still needs a human to monitor and intervene if needed? Okay, level 4. Final answer, Puan? Okay, level 3 and also can be moving into level 4. Okay, thank you very much.
So jawapan yang betul
Question,
ialah level 3.
Level 3.
Level
Yes.
3.
Level 3,
Okey.
but untuk Puan ni.
Oh, okey.
Thank you.
Okay, so thank you very much Encik Azwan. So that's all the quiz for our physical attendees. Encik Azwan dijemput duduk dahulu. Kita teruskan dengan sesi online Kahoot kita. Hold on let me share the screen. Okay, bersedia semua? Pin kejap Okay, this one. Okay, so MCMC staff, please put in your MCMC staff ID ya. Scan the QR code or you can go to www.kahoot.it and then key in the game pin as stated on the screen. Total as usual, kita ada 5 soalan sahaja. Okay, to create the sense of funness and also more engaging, public pun nak join pun boleh. Tapi just be aware that the top 5 winners are all from among MCMC staff only. So MCMC staff sekali lagi diingatkan, use your MCMC staff ID and then check dulu ya, make sure betul. Make sure yang staff ID tu ialah betul. Okay, semua dah masuk kita start Ada lagi ke? Alright, kita start. Okay, total 5 soalan ready semua? Start. Sorry, walaupun saya upload tapi saya pun tak ingat jawapan dia apa. Apa main purpose of remote operations? Oh, kat sini Okay. Mana jawapannya? Apa jawapannya? Oh, okay. Meh. Okay, jawapannya ialah kuning. To monitor and control assets from a distance. Betul? Dapat jawab betul? Okay. Okay, moving on to our second question. Mana? Ni senang ni. Yes, jawapan dia ialah sensing, analytics and action. Okay, third question ya. Ready? Of course, jawapannya ialah drones. Okay, next. Hmm. Yes, jawapan dia 4G and 5G, betul. Because, betul biru. Because I'm not sure why tadi soalan tu kata multiple, but no, the answer is satu saja. 4G, 5G network. So I'm not sure, sebab saya ingatkan tadi soalan tu mungkin saya salah select, but somehow jawapannya betul lah, satu saja. So mungkin tadi salah notification yang keluar ya, tapi jawapannya satu saja, 4G and 5G. So majority betul. Okay, so last question ya, ready semua? Okay, our last question. Level 1. Okay, apakah jawapannya? Okay, tadi remote. That's the correct answer. So, jom kita tengok siapa pemenang top 5. So, please be reminded yang pemenang top 5 yang tertera sekarang ni, kita akan also, pihak KMRC, saya akan also verify and recheck again to make sure that the 5 of you are all MCMC staff. And these 5 people are not from KMRC and also not from the Stakeholder Future Enablement Division. Okay, but congrats to the top 5 winners and also to our 3 physical winners quiz just now. Alright, so top 5 winners dapat? Dapat? Wah, power 1! Farhan, screenshot Farhan. Screenshot simpan buat kenang-kenangan. Bukannya senang nak dapat nombor 1. Okay everyone. So with the end of our Kahoot online quiz, so that's all our knowledge sharing session for today. So before we end the session, again I would like to thank to our speaker Encik Muhammad Hazwan bin Abdul Hafiz from A2Tech Sdn Berhad, and also to the Stakeholder Future Enablement Division. Thank you so much for sharing with us today. And lastly, thank you also to our online and also physical attendees for joining our knowledge sharing session today. Next knowledge sharing that we have that is open for the public is going to be on next week on the 22nd of October. So we hope to see you there again. So all right, everyone. Thank you so much. I'm Aisha from KMRC. Hope to see you again next week. Bye-bye. So our physical attendee seperti biasa nak minta, nak jemput untuk naik ke pentas, kita nak ambil gambar group dengan speaker ya.